This is Predictions, the podcast about our future. I'm your host Konstantin, and I'm here with my brother Ingmar.
Hi, today we want to talk about flying electric taxis. There have been a couple of investments and new companies being founded in the recent years that are trying to solve the problem of transportation in urban areas using flying taxis, which are mostly electric helicopters or also other aircraft, small aircraft with capabilities for vertical takeoff and landing that can carry like 1 to 4 passengers over smaller distances. Konstantin, I think you have an opinion on that.
I think there are three main things that are to solve. So the one is the cost. Right now, a helicopter is a very expensive vehicle. If I'm building something that resembles a helicopter or an airplane, it's going to be expensive. It's going to be expensive to operate. The second one, of course, is range, especially if they are electric. There are fundamental problems with batteries that are very heavy. And also, unlike an airplane where you continuously get rid of your fuel and the airplane gets lighter and lighter while you're flying, battery electric flying vehicle always retains its weight. So there are really big range problems, I think. And the third one is noise. If I have a vehicle that's meant to fly in an urban environment, it needs to be silent. There are, of course, multiple startups trying to solve these problems. But I always feel that between making a lot of compromises in all kinds of different directions, as soon as they get closer to reality, the kind of problem space that they're able to solve gets smaller and smaller. So we should talk today about the different kinds of approaches that there are. For example, there is this Lilium thing in Munich. The ones that you mentioned before, they got a huge investment recently from Tencent, and they have kind of a vehicle that can take off vertically, is that correct? And then it changes the thrust direction and it starts flying?
Yeah, I think it basically has some type of impeller integrated into the wings, and I think it's like 36 impellers into a main wing and another aerodynamic surface, which is almost like a rudder for a normal aircraft, and it can take off vertically and then kind of go over to airplane-like flight. I think that's the idea, at least.
Yeah, so an impeller is like a propeller that's enclosed like in a tube.
I think so, yeah, maybe. I hope I didn't misuse that word, but that's my understanding. Yeah.
So it kind of takes off vertically by blowing air to the ground, and then it changes the direction of its fans, and it starts blowing air to the back, and it starts flying using wings. Yeah. And that's, of course, horizontal flight is much more efficient than vertical flight. And so they want to have a huge range. They claim they get 300 kilometers of range, flying 300 kilometers an hour. So they claim they have about an hour of flight time.
But I think there are people heavily questioning that.
So the thing hasn't flown yet. I mean, it has flown like 2 minutes. But it hasn't flown with a passenger in it for 2 minutes, and it sure as hell hasn't flown 300 kilometers.
Yeah.
And there was like, I don't know if you have read it, this thing in some kind of German aerospace magazine, special magazine, and where they kind of presented the calculation, just in terms of aerodynamics, how much energy do you need to lift this thing? How much energy do you need to go from vertical flight into horizontal flight? And what, do you remember the numbers?
I don't really, but I think what they came up with is that they're not able to sustain flight for more than 3 minutes or something. So it was really like it was a difference to what Lilium is claiming.
Yeah, so I think they came up with that they will use like 80% of the energy just for takeoff and landing. Because that thing is not built as a helicopter, it's built as an airplane. And if you just point your airplane engines down, it's very ineffective, inefficient. And so they just did some assumptions about the weight of the thing, the weight of the battery pack. And they kind of estimated with very favorable terms in favor of Lilium how much energy they need to take off and to land, and then they have like a little bit of energy left that's enough for like 1 or 2 minutes of gliding flight. So they say basically this is nowhere close to happening.
Yeah.
The response by Lilium was that they said they will have higher capacity batteries.
Exactly. And I think that this is kind of the reason why there's such a huge discrepancy between what they are showing and what they are claiming to do, is that they are just assuming that battery technology will advance so fast and so profoundly that at the time they're like producing this, they will be able to have 300 kilometers of range, which, I mean, it's hard for me to assess how realistic that is, but I think that's where this comes from.
I don't think it's realistic. I mean, even if you get, like right now, the efficiency, the specific energy of a lithium ion battery is like 200 kilowatt hours per kilogram.
Yeah.
I hope, if I'm not orders of magnitude off, then this is roughly it. It's something with 200, and they are saying they are working with ones that have 300, so it's a factor 1.5. And I don't think that gets you from 0 to so much. I mean, of course, the most of energy is wasted in takeoff and landing. So if they already have that covered, then the remaining energy all can go into flight. But also, you need to have some reserves, right? If you fly 300 kilometers an hour, if you fly 300 kilometers wide, you're not always super close to a landing pad. So you can't just run your battery down to 0 every time.
Shut off the engine and try to glide into the airport. Yeah, but I agree. I mean, I try to be polite, but I mean, if you can believe what this magazine published there, and I think it's certainly a little bit more credible than the PR speak of Lilium itself. Yeah, it doesn't look like this is anywhere near realistic, right?
Yeah.
But actually, I wanted to talk about another point you were talking about, which is the cost. And this is, like, I mean, the interesting thing about this new area of electric vertically taking off and landing vehicles is that it feels like those companies are trying to combine many different fields of innovation that have really grown over the recent years and are trying to find out if all those technologies could be combined into creating something new. And from that point of view, it kind of makes sense because, like, of course, historically, you couldn't build such vehicles because it didn't make sense, but there are some things that have changed. For once, you have electric propulsion in general becoming better.
Yeah,
but the other thing
have
is
become
also
much lighter. The motors have become much lighter because you have stronger
Yeah.
magnets, and so you don't have so much weight in the electric motors. They're much more
Yeah,
powerful.
but
and more
also, I
reliable.
mean, I think the bigger role plays that batteries have become lighter as well. So
of course,
yeah, I mean, compared to like 20 years ago, so that, I mean, at least it's interesting. And the other aspect is that all of them are trying in the long run to lower the costs of flying by using autopilots. And this is actually something I find quite elegant because it's much easier to solve autonomy for flying vehicles than for cars. And while many people are talking about having autonomous cars, maybe it could also play a role for such low distance transport.
Yeah, I think for an airliner, autonomy is a bit further away. Of course, they're always flying autonomous already to a far extent, especially in automatic landing. But you always want to have a pilot on board just because it's such a high risk environment and it's so far away from a place where it can land and so on. But if you have a helicopter, basically, maybe not the thing that Lilium has, but if you think about another company, I think they're called Volocopter, and they're building basically like a DJI Phantom in big. Like a drone with a couple more propellers. That thing you can always land relatively quickly, and so if you get into bad weather or in any unknown situation, it's usually a quick out.
Yeah, and also the cost savings potential in normal commercial airplanes is much smaller because I don't know what the exact number is, but I would assume that every passenger is paying like $10 for the pilot, probably less even, and I mean, in those kind of...
on Ryanair is like 10 cents.
Yeah. But I mean, in these kind of air taxis, of course, the proportion of the pilot's pay and what you pay for the actual ride would be much higher, right? It's like comparing, like if you go somewhere by train, like every passenger pays like $50 for the train operator, but if you take a taxi, it's almost all of the price.
Yeah,
so it makes much more sense economically to try to solve those short distance and small vehicles autonomy over completely solving autonomy of commercial airplanes.
Yeah, true. It's true. Yeah, it's especially true for trains. I think it's a very important point that train conductors are not a big cost factor.
Yeah.
Though they are a bit of a reliability factor sometimes. So.
Yeah, sure, but I mean, it's easy to automate that, like comparably easy, but it really doesn't make sense. It wouldn't. I mean, of course, at some point it would make sense, but the potential is not so high that you would try it at first, I would think.
Yeah, but I agree. I mean, I think from all the 3 points I listed, cost savings, range, and noise, I think the cost savings are the one aspect where I think we have to give most credit to these startups, because I think that's where really there is a good argument to be made that with the improvement of, and especially the reduction in cost of microprocessors, the reduction cost of electronic components, reduction cost of motors and batteries, and specific energy of batteries, so the amount of energy per weight, there is a chance that these vehicles can be manufactured more cheaply. But also, I'm thinking like if I look at a helicopter, how much does a helicopter cost? Do you know? Blanks there. I have no idea. I guess it's like a couple $100,000, $500,000.
A small helicopter. I think a small helicopter, a 2-seater, not like your typical rescue helicopter, but a small private helicopter, a 2-seater. I think it's about $500,000.
Yeah. So why? Why does it cost so much? Like in the end of the day, it's just a car, right? So what does it make expensive? And does this thing that makes the helicopter expensive, does it still apply to these new startups like Volocopter?
Yeah, I would think. I mean, just off the top of my head, I would assume that it's two things, and which are like, first of all, it needs to be very reliable. So it's even harder to develop a good helicopter than to develop a car, because like your safety requirements are higher, and you have like the system in itself needs to have more redundancy, I would assume. Yeah. And the other thing, of course, is that it's just like such a niche product that you're not going to to sell tens of millions of it. So of course it's more expensive than a car.
Yeah, so economies of scale, of course, that's something that still applies to these startups. This air taxi startups, unless they reach a huge market, which they won't until they reach economies of scale. And so it's a bit of a chicken egg problem, but also I think we'll talk about noise and other things later. But I think the other argument to be made is that with electric flying vehicles, you can save a lot of cost because you have more redundancy. Sorry, you can increase your safety because you have more redundancy, and then you have less cost in ensuring your safety. If I have a helicopter, it has one motor in the center, right? It has one thing, one rotor, one axis. So these components have to be absolutely 100% reliable. Because if your rotor blade disappears, then you're kind of screwed. Now, if you look at the thing like Volocopter, they have 18 rotors. Yes. And what I've understood from the interviews I've seen with them is that they work fine even if they lose one or two of those.
Yes.
And then they have a bunch of redundancy also in their control system, which kind of accepts the fact that their rotor disappears and just keeps managing the vehicle. So they don't have to actually prove that their rotors never fail. They just have to prove that they fail rarely enough. And even then, like, the likelihood of 3 of them failing at the same time is extremely low. So they just have to prove that. Yeah. And so then you need some redundancy in the battery pack and so on, but you can also achieve. Yeah. So I think there are fewer single points of failure in such a vehicle than in a helicopter. And the helicopter is also much harder to steer. And so what I'm saying is, like, it's hard to say how much of that potential cost saving is really due to this technology, like what I've been talking about right now, and how much of the cost of a flying vehicle is really about certification, and getting the approval by the air control agencies. And that will also sooner or later apply to these other air taxi startups like Volocopter or Lilium or the other ones in the United States. And so this might drive their costs up. And of course, also in I think in air transport, especially also with helicopters, there is a factor of monopoly pricing. So there are very few manufacturers of airplanes. Usually these are huge companies. And I'm sure there is a factor of 5 that you can get out of pricing an airplane if you have a little bit more competition, which doesn't exist because these things are extremely complex to build. So if you are able to build a less complex machine, like one of these flying taxis, maybe just the fact that there is more competition in the market will drive down prices.
Yeah. Yeah, and I mean, talking about complexity, I would really say that like a big helicopter, like a rescue helicopter, it's a terribly complex machine, right? Because, I mean, you need a turbine and you have your rotors, and the rotors are also mechanically very complex because they are all like their angle has to be controlled. And I mean, like compared to the Volocopter design, which maybe we should explain that, it's just an 18 rotor design of rigid rotors that are not in any way, like you can't change their angle.
Inclination.
Inclination, exactly. But the only thing you can control are 18 motors and how fast they rotate. And of course, the structure is kind of big, but you just have
10 meters.
Yeah, I think it's comparable to a large helicopter, but within this 10-meter diameter, you have like 18 smaller rotors. And everything you have to control are the speeds of those rotors. So I could imagine that you have kind of a complexity shift from pure mechanics, as in a helicopter, to a more control and software problem. So and there the scale is much better. So once you solve the software problem, you just copy the code basically. So
that's true.
I mean, I don't know too much about it, but I would assume that this is kind of an advantage of those multi-rotor approaches, that the actual mechanical structure is actually not that complicated, and the entire complexity is shifted to software. And also, coming back to your remark about noise, maybe we should also quickly mention that the idea between this Volocopter design is also that it's less noisy. I mean, first of all, of course, it helps that it's electric, but also like a standard helicopter, I think the rotor blades rotate so fast that like on the outer side of the rotor blade, they actually are supersonic all the time.
Yeah, that's how you have to.
Yeah, exactly. That's why it's so terribly
I'm assuming,
loud.
I'm guessing, but I'm assuming that's why you hear that.
Yeah, I think so. Yeah, and so this is also a nice thing about the Volocopter, is that because you have more smaller rotors, you can like push down the same amount of air at lower velocities.
Yeah,
and I think that helps with the noise and probably also with the efficiency. I'm not sure.
I mean, this Volocopter they're building is, of course, also much lighter than a standard helicopter because it doesn't have to carry. I mean, it has to carry batteries, which makes it heavy, but it doesn't have to carry engines. And of course, they're using light build materials. And so what you end up
just small. It's just a 2-seater, so it's really
I think they want to increase it a bit, I assume. I'm not sure.
I think it's supposed to stay a 2-seater. I'm not sure, but. So in the beginning they are trying to like have a single passenger and a pilot, and then like in a long run, the idea is to replace the pilot by an algorithm, and then you have 2 passengers.
Yeah, and basically the idea is to imagine it like a huge rotor surface area with many rotors and a small capsule hanging there, and just from intuitively it feels like this thing can be more silent because the rotors are turning less quickly because they go through a bigger area of air, as you explained, and so they run more slowly. And so I think also just the reason why we chose these 2 companies to discuss is because they're such opposites in terms of character and communication. So we mentioned Lilium before, where we think, to be put it gently, they have very optimistic PR, I think Volocopter is much more conservative in what they're talking about. They're promoting a range of 27 kilometers. Is that correct?
Yeah, I think so.
And that they're talking about the things that they can achieve today with the current prototype that they have.
Yeah.
Now, the prototype they have is a bit smaller than the vehicle they are intending to build eventually, so maybe that the range goes up still or down. But they're talking about what they have today. And so they're talking about 27 kilometers of range, a maximum speed of 60 kilometers per hour. Yeah, compare that to Lilium. They say they have 300 kilometers of range, 300 kilometers per hour of speed. To be fair, there are different construction models, right? The Volocopter always stays in helicopter mode, whereas the Lilium thing kind of turns into an airplane. But I think Volocopter is a better study to discuss what you can do with this kind of vehicle, because the data that we get from them, or the data points that we have from them, are more realistic.
Yeah, and also I think they have basically demonstrated that, right? I mean, they already registered a prototype as an ultralight airplane. So it's basically right now it's not licensed for commercial flight, but only as a sport vehicle. Right? So just an ultralight license. So they are already able to demonstrate that range, and they've already reached some milestones. And I think to me it feels a little bit like the numbers they are putting out are a little bit more reliable, and I think most of them are actually demonstrated. So it's actually quite an interesting case study, because they are kind of at this point where they see where they can get, and they still think that this is a viable business. And this is where it gets interesting.
I mean, if you talk about business, I think their vision of how they want to operate, I don't think it's super realistic. Yeah. So the model that they're talking about is that they are going to have mostly point-to-point connections in the beginning. So basically one spot in the city, maybe in the city center, out to another spot in the city. So you could imagine maybe from the main station to the airport, like a quick connection. And so they want to run that. That makes sense. That's reasonable. That's also something that exists already today in terms of a helicopter service. Yeah. So I think in New York you can go to the landing piers in Manhattan city center and then fly to the airport with a helicopter. So as a business model, I guess this works. And if they can do that with their their Volocopter, which is more silent and maybe a bit cheaper to operate, I think that's a viable model. I just don't think it's gonna be a mass transport. So they want to achieve mass transport. They want to make this cheap. They want to get it down on a level like a taxi.
I think a little bit more expensive. So they're admitting that it's going to be a little bit more expensive.
Okay.
But comparable, yes.
Yeah. So comparable like a taxi, which is fair. But I don't think they will be able to achieve the huge throughput that they want to achieve, and that they would need to achieve to reach a price that's a bit higher than a taxi. I think it will still be quite a bit higher than a taxi. And so I think it will remain a niche product. So the reason why I think they won't be able to achieve this high throughput is because it's still a helicopter. I mean, even if it's 10 times more silent than a normal helicopter, you don't want to have hundreds of them flying over your head every hour.
Yeah, I think they said that it's going to be 3 times more silent, whatever that means. I don't know.
Voice is logarithmic.
I think so. So that would be
I have no idea
quite nice. But I think it's I would assume, intuitively, I would think that what they mean by it, that if you run 3 of these next to each other, it sounds like a single helicopter. So of course that would still be very loud, right? And the metaphor they're using a lot is that they want to have some type of flexible, so they want to use it as some type of flexible cable car. So they're actually not imagining to fly with these from everywhere to everywhere like a taxi does, because that would be still too loud. So I think they're acknowledging that. But
and also you can't land everywhere. Right?
Yes,
these things still need some place.
Yeah, exactly. So it's not like it's going to land in your front yard because first of all it's too loud, and second of all it's also there's not enough space to do it safely probably. So what they are imagining is to use it as some type of cable car and have stations at either at each end or at one of the two ends where you really have a huge throughput of passengers, and it kind of like lands on some type of
pad,
carousel.
pad.
Yeah, and and then people can get in, and it's really like every 30 seconds or so a new vehicle arrives, and also the batteries are switched, so they don't have to be charged while remaining in the vehicle. And I mean, it would be very noisy, right? Such a thing.
I mean, imagine you have a cable car, even if it's going over a valley. You have like, I don't know, every 30 seconds you have a helicopter starting. Even if it's a third of the noise of a real helicopter, there better be a good reason for it. And I think it's kind of a bit of an optimization problem, right? Can I reach a throughput that really justifies making that noise, that enough people can use, that there is support in the city for that noise? I don't think there is this optimum. I think if you transport 3 people an hour, that can be tolerated. That's tolerated in certain cities. In Germany, there's less of a tradition to have helicopters running in the city center. But if you transport 100 people an hour, even if those 100 people are huge advocates of your company, those 100 people are not going to sway public opinion that these things are, 100 people an hour are more than 100 people in total population. But you know where I'm going with that. Like I don't see the sweet spot where people are like, oh yeah, that makes sense. I want to have these things running over my head.
I think it would also depend on the route, right? For example, in Osaka, in Japan, we have the airport is like basically an artificial island in the middle of the bay. Yeah. And like if you start somewhere at the coast and just fly over there, I don't really see the problem here, as long I mean, of course there would be a small area of people that are a little bit disturbed, but so maybe there are some routes that you can do, but I mean, I've never seen a helicopter like in person, but I mean, I would assume, and also from their statement, that it should be like 3 times less noisy than a helicopter. I can't really imagine a future where they're like flying from everywhere to everywhere in the city and everybody is okay with that. It just doesn't seem so realistic to me.
I don't think it scales. I mean, in Berlin, you have 4 million people living there. So maybe 2 million of these are commuting to work every day. So you have 4 million commutes every day. Do you want to have 4 million helicopter flights, even if they're super silent? I just don't see it working. Also, in terms of the number of batteries that you need to produce to handle that. Because, of course, flying takes much more energy than driving. I don't see the cost of energy storage going down enough that you really make it a mass phenomenon where like everybody uses it. And if not everybody uses it, then I don't think people want to tolerate it. And I think in cities like New York, you have this kind of helicopter service to the airport for the very rich. And this also works because you have the Hudson River, right? So you land on the Hudson River bank. You take off from there. It's like once or twice an hour, but mostly you only disturb the people right around there. And I think Volocopter will do very fine in that sense. I think they will be able to run a couple of routes if they figure out the technical challenges. And if anyone does it, I think they will be able to run these kind of point-to-point routes. And maybe this will become a service that is no longer just available to the 0.1%, but now it's available to the top 2% or something like that. But I think it will kind of remain a niche. I don't see it. I mean, if you're going to go to the expense of building these kind of landing pads and starting pads where you like fill these volocopters and like exchange the batteries and so on, just to simulate a cable car that's very noisy, why not build a cable car?
Yeah. I mean, it's more flexible. I mean, that's the argument. But then on the other side, realistically, it won't be very easy to establish a new route. So just from a political standpoint, you're probably just as inflexible as with a cable car, you know?
Yeah, and also, I mean, if you want to go flexibly, like, I don't know, there is like a trade show and you want to establish this connection for a couple of days, you still need to have all the infrastructure, at least on one side. And also, I mean, if you want to have a lot of landings and takeoffs, you need to have infrastructure on both sides because you need to shuffle people in and out quickly. So you need a huge heliport on both sides, and that's not something you set up temporarily, I think.
Yeah. I think there are kind of two challenges. So the one is the energy storage, which is, of course, limiting everything else. It's limiting costs and it's limiting range. And I don't know, maybe you're very optimistic and also you believe in this future where you have unlimited supply of energy. Then you could see that problem kind of vanishing in some time. But the other thing, the noise problem, I think it's kind of more fundamental, because in order to get your helicopter flying, you have to, in quotes, push down that amount of air or that mass of air per time with a certain velocity. And I don't know how much you can do about that, right?
Yeah, I mean, in general, I think just moving the air around doesn't need to be noisy. The noise is, I think, a different frequency than just having a wind tunnel. You know what I mean? Like just the airflow, just the wind is not gonna make that amount of noise. It's gonna be prohibitive from landing in everybody's backyard, of course, but it's not gonna be prohibitive from starting a landing. I think the noise is really more the rotor plates, and I think there is optimization potential. I'm less worried about the noise. I'm more worried about the energy, because even if you, as you say, we have abundant energy, you still need to have abundant energy storage, and it still needs to be. So there's a limit, right? Like if I add more and more batteries to a flying vehicle, there is a saturation where I just can't increase my distance anymore, and just adding more batteries doesn't get me any further. And so these things are limited to 27 kilometers, which, then also limits their kind of purpose, because and that kind of these kind of long, short distance connections, you also have subways and you have buses and you have trams. I don't know,
but I mean they may be slower and less flexible. So if it's not that expensive, and if it's not that noisy, I could see the case there. But yeah,
I think the other interesting question is, can we solve the range problem? Because if you could have these things flying not just between the city center and the airport, but maybe between one city or another city, then I kind of could imagine they're a bigger market, where they're kind of suitable for short distance air travel.
Yeah, I mean, you already mentioned it. You have the problem that the more range you want to have, the more batteries you have to add, and then you run into a saturation problem. And it's worse, and it's also faster than for petrol engine airplane or kerosene engine airplane, because for once you burn the fuel while you fly, while I mean if you draw energy from a battery, it doesn't make the energy or the battery lighter. It just means you have to keep on carrying the dead weight. And also the energy density of batteries is of course much lower than the energy density of kerosene. And one interesting thing that has been talked about, and I think there's also effort to develop this, is to replace the battery with a hydrogen fuel cell. And hydrogen tank plus hydrogen fuel cell in order to produce the energy, the electric energy for the motors. But I think there it's interestingly because the weight overhead you have from the fuel cell is so large. I think it doesn't pay off for those short range vehicles, and it also only gets viable for longer ranges. So I don't know.
Yeah, you need to have a certain amount of energy that you actually want to transport for this fuel cell thing to pay off. If you just have small amounts and the battery is lighter, if you reach a certain saturation, like a certain tipping point, then the fuel cell becomes more efficient, because adding additional hydrogen doesn't cost you as much weight. And hydrogen, of course, has a much higher energy density than a battery.
Yeah, and also after the reaction, so after you have recombined the hydrogen with oxygen in your fuel cell, you can just dump the water overboard, which is also helpful. But I think those fuel cells also have the problem that it's actually not so easy to have the required power. So the power you need to actually lift an airplane or lift a helicopter even is so large that you need many fuel cells, loosely spoken, I think. And this also means that you have more mass. So it's not that easy to just compare the energy density of lithium-ion batteries to the energy density of hydrogen, because the mass of the entire system for hydrogen fuel cells is much larger. And you also have these power problems.
The offset mass, basically the mass that you need to reach a certain power output.
Yeah, but exactly. But also like... If you just keep adding hydrogen supply, it also means that you need more power, and that means you need like a larger fuel cell or something. So I think there's also this also scales.
Yeah.
Right. Yeah.
Yeah, I think the best way to power an airplane with renewable energy today is power to liquid. I take electricity, I create hydrogen from electricity. Then from the hydrogen, I create methane, and then I use this methane to create more complex gases, and then there is a process. For example, I think you can use the Fischer-Tropsch process. What's it called? Fischer-Tropsch?
I've no idea.
Okay, whatever. And then there is a process that gets you to having a liquid fuel, like a kerosene, for example. And now you have kerosene that's created from renewable energy. So all the CO2 that will be created while burning that kerosene has actually been extracted from the atmosphere during the creation of the fuel. And so it's a climate neutral, CO2 neutral fuel. Of course, then you still have loud airplanes, and you still have all the problems that you have with current airplanes. But you kind of fix the climate problem there. This is something that's already been done. Like you can buy this fuel. Of course, it's much, much, much more expensive, orders of magnitude. Or at least 1 order of magnitude more expensive than the traditional jet fuel. But at least it can burn steel beams.
Yeah. But I mean, again, like those synthetic solutions to kerosene, I think this is also very inefficient. And it has other problems. And I mean, as you said, then you're just back at helicopters with all the known disadvantages. So, yeah. I mean, it could be. And I think it's plausible that you can actually use an electric multicopter or helicopter for such a scenario where you only transport people and a small amount of people over small distances. It sounds doable from an engineering point of view. It's just not clear if it's doable from a business point of view, right?
Yeah. I mean, actually, from an engineering point of view, you could also imagine like an electric helicopter, but it has a diesel generator on board. So instead of carrying a battery, it carries a generator and a bunch of fuel, and then it can fly for longer, like a diesel electric engine. So that would also work. I don't think it would be too loud, because you really just have the engine there, not the rotor blades.
Yeah, but I think then you have the hydrogen problems again.
Yeah, probably. Yeah.
And you can't impress your venture capital investors with green energy products. So that's the other advantage.
So to summarize for you, how does it fit into your vision of the future? Do you see a big role for these kind of flying taxis there? And what kind of role do you see?
So I mean, I kind of believe in this future of abundant energy. And within that frame, I could imagine having like a single shuttle from the city center to the airport. And then this shuttle tries to fly a route that kind of avoids annoying people too much, or maybe also like gains altitude very fast. And I don't know. I mean, I could see a case there. I just don't think that it scales to like tens of thousands of people using it daily.
Yeah, I agree. I think the market for airport shuttle helicopter services is something that's up for grabs for these companies, and it can grow. And maybe there are also other markets that then become viable, maybe like island hopping services or something like that. But I don't think it will replace mass transit. I don't think it will replace taxis. So it's not something that kind of keeps me up at night because it makes me so excited about the future. It's kind of like a 1%er thing. But at the same time, I think the technology is super neat. And I think it can replace helicopters to a big extent. Also rescue helicopter operations, by the way.
Yeah, exactly.
Replace.
Yeah.
And so I think that makes it very interesting. And I wish these companies all the best, no matter which company. Because I think if they can succeed, that's of course a very good thing. And
I mean, it's so elegant, right? So the last 2 decades brought more efficient electric motors and, of course, better batteries. And it brought artificial intelligence and maybe cars that are starting to be a little bit autonomous. And also it brought innovation in material engineering. And they are all trying to combine this into making a new product. And I mean, I could totally see it to be used, as you said. But I think it's very elegant because it just combines so many new technologies of the recent decades, and it certainly makes sense in some respect.
Just one little remark there. I'm pretty sure they are not using AI for the flight algorithm. They may use AI for the autonomous steering, detecting birds or something. But I'm sure they don't use AI to steer the helicopter.
Yeah, of course. Yeah, sure. Of course. I mean the position control and all that's just probably hardwired. That's also for regulatory requirements, I guess. That's just probably just a hardwired algorithm. But at a later stage, you maybe want to detect obstacles, and I could imagine it playing a role there. Yeah. But I think we both agree that it won't save the traffic problem of big cities, right?
No, that's gonna be something else. Yeah. Anything else to add?
No, I think that's it.
All right. Thank you. So if you like this podcast, do not forget to hit the subscribe button or whatever podcast app you're using, Apple, iTunes, Spotify. We are there. Don't forget to subscribe and maybe leave a review. But of course, only if it's a positive one. Otherwise, just send us an email. You can also email us at mail@predictions-podcast.com. We are really looking forward to your feedback, positive and negative. And we'll be crying ourselves to sleep when we hear it. Thank you very much.
Exactly. Yeah. Just yell at us if we said something that was terribly stupid.
And we will apologize 5 minutes next time.
Okay.
See you next week, man.
See you.